Okay, so I had to pause because I can only make 15-minute videos here. And again, you're going to do D because it's just like A. And you're going to do B because it'll be just like C. So C is not quite like A or D because, again, in order to complete the square, it needs to be an x squared. So I can kind of think of this as having a -1 in front. So I'm going to factor out a -1, which turns it into x squared plus 4x. And then add your blank, or again, I told you could think of it as a square because you got to complete the square if that helps. And now I'm going to start the process. I'm going to take 4, I'm going to cut in half, and that's 2. And then when I square 2, I get 4. So I'm writing 4 down, but as it turns out, where this is really worth -x squared, and this is really worth 4x, what I wrote down is really worth 4. So I'm sorry, it's really worth -4, even though I wrote 4 down. So I'm really adding -4, which means over here I'm going to subtract -4. And then when I go to work on this part outside, I would add the opposite. So it really just becomes 1 plus 4, so I get a 5. And then in my parentheses squared, I'll have x plus that 2. What's in front of the squared here is in front of the squared here. And then I'm not going to forget about the -1 that I took out. And there's my answer. So you'll do B the same way. You'll have to take a 2 out of both of these before you start this completing the square. All right, we are getting there. All right, a rectangle has a length of 2x plus 3 and a width of x minus 1. So I'm going to just draw this rectangle over here. So let's say this is the length, 2x plus 3. And this is the width, x minus 1. And I need to find the perimeter and I need to find the area. So perimeter, if you remember, is where you add all 4 sides up. So that's what I'm going to do. I'm going to take and realize that these are opposite sides are equal, and I'm just going to add these up. And remember, when we did add on that first page, okay, well, if I can get back there, that we stacked our like terms. And so that's all I'm going to do here. We are stacking our like terms. So I'm going to stack them as 2x plus 3, x plus -1. I'm going to add the opposite on it, another 2x plus 3, and another x plus -1. And then I can just add these up. So when I add these up, I get 2. I add these up, that's another 2. So when I add these all up, I get 4. And 2x and 1x, that's 3x. Add another 3x from here. So when I'm done, my perimeter is 6x plus 4. Okay, now I'm going to find the area. Area is where you take the length times the width or the base times the height. So I'm going to take 2x plus 3 times x minus 1, and when we multiply, this is just neighbors meet neighbors, so I'm going to multiply these. So 2x goes to visit, and I get 2x squared with a -2x, and then 3 goes to visit, and I get a 3x with a -3, and then I can add these up. So when I'm done, my area will be 2x squared plus 1x plus -3. Okay, so there's the area. And finishing up the last. So the idea is to find equivalent expressions of these. And there is a section like this on the test. It looks a little different, but it's doing the same thing. So the idea is, if I give you standard form, could you, for instance, what's the word? For instance, give me vertex form or factored form. So that's what we're going to do here. I just want another equivalent expression. So for this one, I can actually get it into factored form if I want by factoring it. So just to show you what this would look like. So this is in standard form. What I'm going to have is I'm going to factor this. So I need factors of 16 that get me to 10. And so that's 2x and 8x, and then I can rewrite it, replace 10x with this. So x squared plus 2x plus 8x plus 16. Then with 4 of them, remember we just pair them up. So my GCF out of this first set will be x, and x with x gives me x squared, x with 2 gives me 2x. And then I'm going to have a matching set. So what with x gives me 8x, that would just be 8, because 8 with 2 give me 16. So one thing that is equivalent to this is x squared plus 10x plus 16. So is the factored form, sorry. So this is the same as this. This is just the standard form version, and this is the vertex form version. The other, so there's one version. Another version I could get is by completing the square on it, so just using this box to do all of that. And we just did a bunch of problems, so I can take this, I can cut it in half, that's 5, I can square the 5, and that's 25. So what I did not do, sorry, is I did not do the whole grouping of them yet. Kind of jumped the gun. So I'm going to add 25 here because it really is just 25. There's not a number hanging out here, so I'm going to take away 25. And then when I focus here, 16, take away 25 is -9. And then in my parentheses squared will be the x plus 5. So as it turns out, on the test, you'll need to come up with 3 versions of something that's equivalent to this. So here's one, or so here's the original, here's one equivalent version, here's another. So I need one more. So I just need something that if I put it together would give me this. So this is going to be my suggestion on this. You actually have something in front of you that is an equivalent version that is this problem no matter what. So if you guys want to see, I'm going to show you where 2 of them are. One of them is here. This is the same as this because this is still x squared plus 10x plus 16. So where they're asking for 3 of equivalent versions, I'm going to suggest that you just go back and look in your problem, because when you're going from here to here, this is equivalent to this, it's equivalent to this, it's equivalent to this. So you've got something else in there. So I need one more equivalent version. I could use that. Because again, this is exactly the same as what I started with. Okay, so that could be a 3rd equivalent version. On this one, this is factored form. So to get an equivalent version, I could turn it back into standard form by having the neighbors meet the neighbors, for instance. So there's have those meet, I get x squared and I get -4x. Have those meet, I get a 6x and a -24. So what's about to be an equivalent version of this is x squared plus 2x plus -24. So this is just the factored form, and now we have the standard form version of it. And if I want to get another form, I could just take this and get it into vertex form by completing the square. So if I group my x's together, and now I'll just take that 2, I'm going to cut it in half, and I get 1, and 1 squared is 1. And then I can rewrite this part. If I add the opposite, that becomes -25 at the end, and then in my parentheses is x plus 1 squared. So far, compared to this, I have 2 things that are equivalent to it. So again, what I would do is just go back to somewhere where there was a lot of adding, subtracting, and this, if I just write it out left to right, that's another equivalent form. X squared plus -4x plus 6x plus -24. Again, there's this one section that wants you to come up with equivalent forms. All right, so what could I do with a problem like this? Well, this is definitely the toughest one. So this is vertex form. The first thing I could do is, have a lot of neighbors meet and get this into standard form. So I'm just going to write this out the long way. And I've got 3 neighbors here. So which neighbors should meet first? I always like to start with the parentheses, the ones with the x's. So I'm going to have these neighbors meet first. So I'm going to get x squared and 2x. And then 2 is going to meet, and I'm going to get another 2x and a 4. So when these neighbors have met, I now have x squared plus 4x plus 4. So bring this 2 down. Here's that -18. So we're just continuing the problem. So now 2 can meet the new group. So going to meet everybody. And then there's a -18. And then I can clean this up by just combining those like terms. So now this problem is in standard form. So here's one. We'll go for another one. I'll just complete the square on it. So remember, when I complete the squares and I group these x's together, I'm just going to rewrite it here, that it's got to be x squared. So I'm going to take that 2 out. Okay, almost done. So now I'm going to take the 4, I'm going to cut it in half, that's 2, 2 squared is 4, I'll put the 4 there, I'll put the 4 there. So what does this give me? I'll get -14 here, and then I'll get x plus 2 squared. Okay, and then what is an equivalent form to that? Again, just go somewhere where you saw a lot of adding and subtracting, like up here. This had a bunch of adding, subtracting. That could be another equivalent form. There are equivalent forms all the way throughout, and that's still a really new topic for us. And I wish they didn't have this type of question on the test, but they're going to. So just to know, you know, when we're doing all this math to get one from one form to another, that is working with equivalent forms. And that's it. So tomorrow when you get to class, you need a calculator. I won't be loaning these out. And bring your flip book in for the test. And we will do the first parts. That will be mainly factoring on the first day, and then we'll finish up on Friday, and that will be mainly completing the square. And that's it.